Hello guys, we will be solving the problem marbles. Here we are given n boxes and m marbles, and the boxes are numbered from left to right, and the number of marbles in the ith box is denoted by AI. Now Bob wanted to arrange these marbles in non-increasing or descending order from left to right. Here non-increasing means that the number of marbles in the box I should be greater than or equal to the number of marbles in the box I plus 1. For all the boxes, we have to make it non-increasing. Now, Bob can perform moves through which he can make the number of marbles in each box non-increasing. So, a move can only be considered if we pick a marble from box I and we will place it in either of the adjacent boxes, that is, in either with the box with index I minus 1 or box with index I plus 1. Now we have to find the minimum number of such moves required to achieve a non-increasing arrangement of marbles. So the input format is like the first line consists of integer t, which is the number of the test cases. Then in the first line of each test case, there are two space separated integers, n, which represents the number of the boxes, and m, which represents the number of the marbles. Now in the second line, there are n integers, which represents the number of marbles in each of the n boxes. For the output format, we have to print a single integer, which is the number of the moves required. Let's take a look at the sample input. Here, 2 is the number of the test cases, 6 is the number of the boxes, and M here is 19, which is the number of the marbles, and here we are given the number of marbles in each box. Similarly, in test case 2, 3 is the number of the boxes, 6 is the number of the marbles, and similarly, the number of marbles in each box is given. Now, let me explain you the sample test cases. Case 1, 6 is the number of the boxes and 19 is the number of the marbles given, and we have to make it in a non-increasing pattern such that the box I has greater or equal the number of the marbles in the I plus 1th box. So here, according to the explanation, we have to move the marbles from box 1 to box 2. So let's move it. So after moving the box marbles from box 1 to box 2, the number of marbles in box 1 reduces by 1, whereas in the box 2, the number of marbles increases by 1. This is the move 1. Now for the move 2, we have to move the marbles from box 2 to box 3. So let's move it. After moving the marbles from box 2 to box 3, again the number of the marbles in the box 2 reduces by 1 and in the box 3 it increases by 1. Now here the non-increasing arrangement is satisfied with the minimum number of moves, that is 2. For the test case 2, 3 is the number of the boxes and 6 is the number of balls given, marbles. And here we can see that it already follows a non-increasing pattern. So the number of the moves will be 0. The code will be in Java, and for the approach one, we'll be using dynamic programming. So here I have imported all the Java utilities. Then we have a class named Marbles. For the main method, we have a scanner object which will help us in taking the inputs. T is the number of the test cases. Then for each test case, we'll be take input the number of the boxes, which is n, and the number of the marbles, which is m. Now we have declared a prefix sum integer array, which will have indices from 0 till n. So for the boxes here, we'll be using one-based indexing. So the prefix sum array will store all of the cumulative value of the marbles from the box 1 till that ith box. So we'll be using the for loop to store the cumulative values. Now we will have a DP table here. The DP box used marbles represent the minimum number of moves required to reach that box using those number of used marbles. We will initialize all of the values in the DP table with infinity. Then for the base case, if we have 0 boxes, 0 marbles, then there will be 0 moves. So we will initialize DP00 to 0. Now here we have three for loops. For the first loop, we have iterated the marbles in the reverse order. to ensure that the boxes are in a non-increasing fashion. So here marbles will start from M and will go till it is greater than or equal to 0. Then since boxes have one base indexing, so we'll go from 1 till n. Then we will have a used marbles which will start from marbles till the maximum number of marbles given in the question. Here, used marble helps us to know how many marbles have already been placed in the previous boxes, whereas marbles represent the number of the marbles we are taking into consideration in that iteration. Now, we'll check if all the previous states have been computed. That is, it is not equal to integer dot max value, and if it has been processed, then we'll go further. If it has been processed, then DP box used marbles represent the minimum number of moves required to distribute the used marbles among the first boxes. So we will check if it is already um, efficient and it is already smaller, or we'll check that the minimum number of moves to distribute used marbles minus marbles in the previous boxes, plus we will take into account the adjustment cost, that is the moves required to match the prefix sum of the first boxes with used marbles, and we will take the minimum of these values. Then we will print DPNM. Here, DPNM represents the minimum number of moves through which we can distribute M marbles among N boxes in a non-increasing fashion. Then we'll close the scanner, and now let's take a look at more approaches. Different approaches. As for the approach one, we have already used the dynamic programming approach. Then for the brute force, we have a backtracking approach where we will generate all the possible distributions using recursion and check if it is valid. And we will compute the number of the moves required and return the minimum among all possibilities. Then the third approach is of binary search plus greedy approach. Instead of iterating as we're done in DP, we will use binary search on the minimum number of moves required. For each mid value, we check if it is possible to distribute marbles within mid moves using a greedy approach. So feel free to try all of these approaches, and we have already solved it using dynamic programming. So thank you.